Hello, everyone. Welcome back. Good afternoon. I'm Steve.
And I'm Scott.
And together we are Backyard Musings broadcasting live Apple Valley, California.
Science technology is still what we're talking about.
Got another NASA. This is really interesting.
Yeah.
NASA's Mars Reconnaissance Orbiter has learned to pull off daring 120-degree rolls that give its SHARAD radar, SHARAD radar, 10 times stronger echoes, exposing hidden ice and geology more than a mile underground just by flipping it.
Unbelievable. How is that possible?
Engineers painstakingly schedule these flips to keep solar arrays powered and antennas linked with juggling 5 competing instruments. The fresh trick revives a 19-year-old spacecraft, often helping the Mars Climate Sounder stay in action after its pivot failed, and promises a richer view of the red planet's resources, climate, and past habitability. The breakthrough is highlighted in a new paper published on June 11, 2025 in the Planetary Science Journal. Would you like to know more?
After nearly 20 years of exploring Mars, NASA's Mars Reconnaissance Orbiter is proving it still has a few surprises left. Engineers have recently taught the spacecraft a bold new move, rolling nearly upside down to unlock a deeper view beneath the Martian surface. This new maneuver, which describes 3 of these dramatic, very large rolls carried out between 2023 and 2024, allows MRO to search even more effectively for signs of liquid and frozen water, along with other buried features that could reveal Mars's hidden history.
So I wonder which scientist came up with this bright idea to try a roll and see what happens. That dude deserves a medal.
Maybe got one.
I hope so, man.
Got a couple days off.
And a chest to pin it on, too.
Yeah.
All right, MRO was originally built to roll up to 30 degrees in any direction, allowing it to aim its instruments at features like impact craters, ancient riverbeds, and potential landing sites. But now, engineers have pushed it even further.
The process for rolling isn't simple. The spacecraft carries 5 operating science instruments that have different pointing requirements. To target a precise spot on the surface with one instrument, the orbiter has to roll a particular way, which means the other instruments may have a less favorable view of Mars during the maneuver. What if you like say, okay, let's roll, and you roll, and keeps on rolling.
It does.
Yeah.
You better hurry up, get your view.
Better get back that medal. Yeah.
That's crazy.
These guys are amazing.
Send out the repair guy.
This equipment is even more amazing.
That's why each regular roll is planned weeks in advance, with instrument teams negotiating who conducts science and when. So I can see this negotiation across the table start to come to warm blows. No, it's my turn. No, it's my turn.
How am I supposed to negotiate when you got mayonnaise on your face? Come on, wipe that off your face.
You got pens in your pocket. You must protect them.
Yeah.
Stop, man.
Stop it. These guys are amazing.
Then an algorithm checks MRO's position above Mars and automatically commands the orbiter to roll so the appropriate instrument points at the correct spot on the surface. At the same time, the algorithm commands the spacecraft's solar arrays to rotate and track the sun and its high-gain antenna to track Earth to maintain power and communications. So this is a handy-dandy instrument.
Yeah, and I'm just trying to think, okay, so there's a delay. There's got to be a delay, right? Yeah. So you tell it to roll, 15 minutes, and then you got to wait
10 minutes.
Make sure it does it. And then, I don't know, it's just mind-boggling. A lot of patience.
That's why you plan it way in advance. Yeah.
Negotiate.
This is
very large rolls, which are 120 degrees, require even more planning to maintain the safety of the spacecraft. The payoff is that the new maneuver enables one particular instrument called the shallow radar, or SHARAD, to have a deeper view of Mars than ever before. Again,
sounds like a love story.
I just don't get that, how they can do that. They can see, what did it say, a mile into the surface?
Yeah, maybe it's the instruments that are up there that they weren't using for that purpose. I don't know. Yeah. Designed to peer from about half a mile to a little over a mile, 1 to 2 kilometers, below ground, SHARAD allows scientists to distinguish between materials like rock, sand, and ice. The radar was especially useful in determining where ice could be found close enough to the surface that future astronauts might one day be able to access it. And why is that important? You split water into hydrogen and oxygen. Hydrogen as fuel, oxygen to breathe. That's why it's important.
And this next line is important too.
Ice will be key for producing rocket propellant for the trip home and is important for learning more about climate, geology, and potential for life at Mars. Yeah.
There you go.
There you go. There you go.
To give cameras like the High Resolution Imaging Science Experiment, or HRSI, I guess you'd have.
HiRISE.
HiRISE?
HiRISE.
HiRISE. Okay, not HRSI. Oh, yeah. Prime View. Where'd I get
HiRISE, man.
Where'd I get HRSI out of that? I'm looking for chocolate bar, yes. Prime viewing at the front of MRO SHARAD's 2 antenna segments were mounted at the back of the orbiter. While this setup helps the cameras, it also means that the radio signals SHARAD pings onto the surface below the encounter parts of the spacecraft, interfering with the signals and resulting in images that are less clear.
Okay. Quote, the SHARAD instrument was designed for the near subsurface, and there are select regions of Mars that are just out of reach for us, said Morgan, a co-investigator on the SHARAD team. There's a lot to be gained by taking a closer look at those regions.
In 2023, the team decided to try developing 120-degree very large rolls. There's one right now. That must be what it sounds like. To provide, there, it's even better.
That's the tile
To
guy.
provide the radio waves an unobstructed path to the surface. What they found is that the maneuver can strengthen the radar signal by 10 times or more, offering a much clearer picture of the Martian underground.
Okay, so it enhances it 10 times or more.
Yeah.
Okay. But the roll is so large that the spacecraft's communications antenna is not pointed at Earth, and its solar rays aren't able to track the sun. Given the time involved, the mission limits itself to 1 or 2 very large rolls a year. But engineers hope to use them more often by streamlining the process. I didn't know it was 1 or 2 a year.
Yeah.
I thought this was like
And
weekly.
And then when this doesn't happen, you heard the penalty in the background just a few minutes ago. While SHARAD scientists are benefiting for these new moves, the team working with another MRO instrument, the Mars Climate Sounder, is making the most of MRO's standard roll capability. The JPL-built instrument is a radiometer that serves as one of the most detailed sources available of information on Mars' atmosphere, measuring subtle changes in temperature over the course of many seasons. Mars Climate Sounder reveals the inner workings of dust storms and cloud formation. Dust and wind are important to understand. They are constantly reshaping the Martian surface, with wind-borne dust blanketing solar panels and posing a health risk for future astronauts.
Yeah, I don't know how. It's not like they would take their mask off and breathe it in. So
yeah, so it kind of reminds
risk.
me of that one opening. I think it's the opening scene of Empire Strikes Back, when that guy's bouncing around on that creature that kind of looks like a T-Rex.
The Tauntaun.
He's all dressed in snow gear and stuff.
That's a Tauntaun.
Yeah, and the weather is terrible, so that's what they're gonna have to deal with.
Those are called Tauntauns. Say
Tauntauns?
that. Tauntaun.
You mean the creature?
The creature, yeah.
Tauntaun.
Yep. Mars Climate Sounder was designed to pivot on a gimbal so that it can get views of the Martian horizon and surface. It also provides views of space, which scientists use to calibrate the instrument. But in 2024, the aging gimbal became unreliable. Now, Mars Climate Sounder relies on MRO standard rolls. So we need to get a repairman up there. You know what I'm saying?
Could take a while.
Tweak all these things.
Could take a while.
Well,
yeah, but this is cool.
Very cool.
This is what's happening in our final frontier or last frontier, whatever frontier it is. But this is very cool.
Thank you for joining us, folks. We appreciate it.
Yep. Thanks. And thanks for all the comments and subscribers. So take care.